So we've been looking at graphs. We've looked at a library of functions you should be familiar with. We just talked about piecewise functions and graphing piecewise functions. Now we're going to look at transformations of functions. So using transformations to help us graph a function if possible. And so our objective after we cover the material in this section is that you can graph functions using vertical and horizontal shifts. You can graph functions using compressions and stretches, and you can graph functions using reflections across the x-axis and the y-axis. So for the first piece, we're looking at vertical shifts. And so if you're looking at some function f of x, and you're adding a constant k to that function f of x, then we have a vertical shift if k is bigger than 0. So that was stated in words, and now let's go through and just read what it says. If a positive real number k is added to the output of a function y equals f of x, the graph of the new function y equals f of x plus k is the graph of f shifted up vertically k units. So let's just look at a quick example. We know what the graph, or you should know what the graph of f of x equals x squared looks like. And it's a parabola shape. The vertex is at 0, 0. Plug in 1, you get 1. Plug in -1, you get 1. Plug in 2. 2 squared is 4, etc. -2, we get +4. So we get this graph that looks like this. But if we were to look at f of x, maybe let's call it something different. Let's call it g of x. Let's say g of x was equal to f of x plus 2. So another way to write g of x, f of x was x squared, so x squared plus 2. So the number that we're adding is positive. So this tells me that I am going to shift x squared up 2 units. Technically, my x value on my graph of f of x, my new point on g of x, my x value is going to stay the same, but shifting things vertically affects my y point, or the y value of my point. And so we'd have x comma y plus k. Except my k value in this case is 2. So my 0.00 that was on the function before of x squared plus 2, that point would now be 0, 2. My point here at 1, 1, shifting that up 2 units is now going to become 1, 3. -1, 1 will now become -1, 3. My 0.24, shifting it up 2 units is going to be 2, 6. -2, 2 would become -2, 6. So this is our graph of g of x, which is f of x plus 2. If we're adding a negative number, or another way to say it is for subtracting some number, then that shifts the graph of f of x down k units. So reading through what's given to us in front of us, if a positive real number k is subtracted from the output of a function y equals f of x, the graph of the new function f of x, or y equals f of x minus k, is the graph of f shifted down k units. And so for instance, if we had had h of x, this is equal to, let's say, f of x minus 2. So our point xy and f of x is going to become x comma y minus 2 on our new graph. And so our point that was at 0, 0, x stays 0, but my y value is now negative 2. My point 1, 1, x is 1, but subtracting 2 from 1 gives me negative 1. My point negative 1, 1 now becomes negative 1, negative 1. My point 2, 4 going down 2 is 2, 2. So negative 2, 2. So this just shifts down my graph of f of x down 2 units. Okay, so adding or subtracting a number to a function, so it's outside of a function, it affects it vertically. So now let's look at another transformation, which is our horizontal shift. So horizontal shifts, this is where we add or we subtract a number inside of the function. And that is going to shift our graph horizontally. So horizontal shift, if the argument of x of a function f is replaced by x minus h, where h is bigger than 0, so we're subtracting some positive number, the graph of the new function y equals f of x minus h is the graph of f shifted horizontally h units. Shifted horizontally to the right h unit. So this is actually opposite when it's inside of what we think it's going to do. Just to make life easier, let's just keep with y equals, or f of x equals x squared. Plotting our points, again, we got 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And let's call this f of x. And f of x is equal to x squared. So if we have g of x, and g of x was said to be, let's say, x minus 2 inside. Well, this tells me I'm going to go back to my function f of x, right? And wherever I see an x in my function f of x, I'm replacing that with x minus 2. So put a parentheses where you see an x. Inside the parentheses, replace it with what the argument is, in this case, x minus 2. So this minus 2, this shifts f of x to the right 2 units. So if xy was a point on our graph of f of x, then our new point on g of x, well, you're adding 2 to your x value and your y value is staying the same. So this 0.00, my y value is going to stay 0, but my x value, I'm going to sum 2 to it. So 0 plus 2 is 2. So I have this 0.00 now becomes 2, 0. My 0.11, y is going to stay the same as 1. but I'm going to add 2 to 1, which gives me 3. So now I have a point here at 3, 1. My point that was at negative 1, 1. Adding 2 to my x value, so negative 1 plus 2 is 1. Y value stays the same of 1. So I have a point here at 1, 1. My x value of 2, 4. Y stays the same. It's my x value that's being affected. So adding 2 to 2, I get back 4. So I have a point at 4, 4. And then our point that we had plotted, negative 2, 4. Adding 2 to my x value, so 2 minus 2 is 0, and y stays 4. So we get this new graph here, which is g of x, which we call g of x. So if we add a positive number, that shifts it the opposite direction. It would shift it to the left that number of units. So looking at this, it says if the argument of x of a function f is replaced by x plus h, where h is a positive number, the graph of the new function y equals f of x plus h is the graph of f that shifts it left h units. So if we had had h of x, let's say, is equal to f of x minus 1. Going into my equation of f of x, plugging in x minus 1 wherever I see an x, I get the equation of h of x is x minus 1 quantity squared. And so this shifts it horizontally to the, oops, I wanted to do plus. I wanted a positive number. So let's just change that to a plus 1. Plus 1. This shifts it horizontally to the left one. So technically my XY value, left one, that's going to affect my X value. So I'm going to do X minus 1Y to get my points. So the point 0, 0, subtract negative 1, or subtract 1 from 0, I get negative 1, 0. So I have a point here at negative 1, 0. My point 1, 1 is now going to become 0, 1. My point negative 1, 1, subtracting 1 from negative 1, we get negative 2, 1. Our point 2, 4, subtracting 1 from 2, we get 1, 4. And the last point that we had on here was negative 2, 4. Subtracting 1 from negative 2, we get negative 3, 4. And so this would be the graph of h of x, which is x plus 1 quantity squared. Okay, so that was the start of transformations. What would happen if the graph of some function f of x had a vertical shift or a horizontal shift? And so we'll look more into transformations of functions next week. We'll look about reflections across the x or y axis. We'll look about at shrinking and stretching our graphs also. So for my class, this was the start of 3.5.